Well, hello guys and welcome back to Mr. G Physics. It's a long time I don't make videos, but I've been having some family problems and some issues, and they've been struggling to make videos with the work as well. But this time we're going to make a video on energy and chemical change. This is in preparation for the upcoming examination, the grade 11. However, in grade 12 is also applicable. Now, when you learn or when you do energy and chemical change in the school, we are going to classify the reactions. All chemical reactions can be divided in two main groups according to the change in energy during the reaction. Those are exothermic reaction and endothermic. Exothermic and endothermic reaction. And if we look at these two words in which we can classify the reaction, we have these prefixes at the front of each of them. Guys, the first one, exothermic. That exo means out. It means out. It's the meaning. It's a Greek prefix. And here, endo, this endo means absorbing or inner or within. So this is the main thing. Those prefixes means those specific words. Exo means out and endo means absorbing. So if we are speaking about energy, which is the main part of this topic, and we have an exothermic, thermic comes from heat, So if we have here this type of reaction is going to give out, heat, or is giving out energy. It does release energy. So the exothermic reaction does release energy. It gives energy away or out of the system. In the endothermic reaction, energy is going to be absorbed. So, in other words, all chemical reactions can be divided in two main groups, in exothermic and endothermic. The exothermic releases energy in the form of heat, for example. The endothermic absorbed energy. It doesn't need to be in the form of heat, it could be in the form of light, for example. So now here, in this chemical reaction, how are we going to write it? We have reactants, and obviously we have product. But because we're giving also energy out, there will also be energy. Alright, that is how we write the exothermic reaction. In the endothermic reaction, is the other way around. We have now reactants that take some energy and then will give the product. Alright, so this is important to know. During an exothermic reaction, we'll start with reactants. Any reactants, we have the product, but also with the product, we're going to be releasing or giving out energy. In the endothermic reaction is the other way around. We have the reactant, will take some energy in, and then we are going to have the product. Now, because we're giving energy here, let's do a graph of energy versus time for each of the two types of reaction, and let's see what happened. So we have, for instance, for the exothermic reaction, we have that the reactants will have some energy. This is reactants. Now, when I mean reactants, I don't speak about the reactants itself, but rather I'm speaking about the energy of the reactants. All right, now this substance of this reaction is giving energy away, so it's going to lose energy. At the end, the product will have some energy which is less than the energy of the reactant. These are the product. But note, when I say product, I don't mean product, but I mean energy of the product here. So that is what you can see here. You have reactant with certain amount of energy. Energy is being given out, so at the end you will have less energy than before because you gave energy away. In the endothermic reaction, there is another story. You have the product with some amount of energy. This one is the the reactants. You always start with the reactants. That reactants is taking energy in. So at the end, the products will have an energy that is greater than the energy of the reactant. This one is the product. Remember, once more, when I say product, I don't actually mean product, but I'm speaking about the energy of the product. So going back, in the exothermic reaction, the reactants have certain amount of energy. It does give away some energy, so the product will have energy which is less than the energy of the reactants. In the endothermic, the reactants have certain amount of energy, and then the product, because the reactant of the system absorbs some energy, at the end you will have a greater amount of energy for the product. So we can say actually that in the exothermic reaction, the energy of the reactants is greater than the energy of the product. And in this case, we can say that the energy of the reactant is smaller than the energy of the product. Remember, we're speaking about energy of reactant and energy of product. Now, what else can you see from this graph? That there is a change in energy. Now, this difference here that you can see there is what we call change in energy. But we are not going to refer to energy, rather we refer to enthalpy. And then it's a good time to speak about enthalpy. Enthalpy is the measure of the total energy of a chemical system for a given pressure. So we are not going to speak about energy itself, but we're going to speak about enthalpy. And the symbol for enthalpy is going to be the letter H. That is for enthalpy. So that is why we refer here to change in enthalpy. So energy of reactant, energy of product, we can speak about the enthalpy of the reactant and the enthalpy of the product. Now, if we look here, remember any change is final minus initial. Final is the product. So that will be the enthalpy of the product minus the enthalpy of the reactants. And now look carefully here as well, because the product is less than the reactant in terms of energy. That means that the change in enthalpy for an exothermic reaction is going to be smaller than 0 or negative. Note the following as well. This graph is not a complete graph. This is just for you to see what happened to the energy of reactant and product. Same happened here with the endothermic reaction. This difference between the energy of reactants and the energy of the product is what we call change in enthalpy, and that is equal to the enthalpy of the product minus the enthalpy of the reactant. And note the following: the energy of the product is greater than the energy of the reactant. Therefore, the change in enthalpy is going to be greater than 0, or we can say that is positive. All right? So here we are. So far, what we know about exothermic and endothermic reaction. Exothermic is the type of chemical reaction that releases energy. It gives energy away. The endothermic reaction, it does absorb energy, you take energy in. Now, if we go back here and you have a reaction, we also find out that in the exothermic reaction, the energy of the reactant is greater than the energy of the product, and that the change in enthalpy is negative, or is less than 0. And in the endothermic reaction, we have that the energy of the reactant is smaller than the energy of the product, and then as a fact, the change in enthalpy is greater than 0 or positive. So far, we have almost everything related to this specific question. Now, something I want to mention here. In the exothermic reaction, because energy is released, the temperature of the system increases. Okay, so if you have a chemical reaction and that reaction is exothermic, you will notice that the temperature increases. The other way, if it's an endothermic reaction, the temperature will decreases. In an endothermic reaction, the temperature will decreases. Well, we are almost done. This topic is not much. But now, the chemical reaction not always happen just like that. They need some energy to begin. You need to, for the reaction to begin, you need some energy. For example, I always give this example. Burning, when you burn something, burning is the reaction between that substance that you are burning and the oxygen. Everywhere is oxygen. However, a piece of paper does not just burn like that. You need something. You need some energy. So you need a lighter, for example. Then if you have a lighter and you light, then you can start the paper for burning. That is something we call activation energy. Now, activation energy is the minimum amount of energy that is needed to start a chemical reaction. There's a T missing here. Start the chemical reaction. We can use the symbol EA if you will. It's not a big problem in terms of symbol. I like to use EA for activation energy. So the activation energy is that energy that you need that is greater than the energy of the reactant. You need more energy than the reactant for the reaction to start. When the reaction begins, then that activation energy is moving down. So if we include here the activation energy, and I'm going to redraw the graph here at the bottom in a new page. And this is the two graphs redraw what we done up until now. We have the energy of reactants, energy of product, we have the change in enthalpy. And just for control, let's write here, this is the exothermic reaction, this one is the endothermic reaction. Now, the activation energy is that one that is greater than the energy of the reactant, is go high up until the reaction start and then move to the product. So all this one does not represent the activation energy. The activation energy is the energy that is going from the energy of the reactant to the maximum energy. So from there to this specific point is what we call activation energy. This difference here, I'm going to write EA as I said before. That one is the activation energy for this specific reaction. For the endothermic reaction, the same story. You have to give some energy to the reactant so the reaction begins, and all this one does not represent the activation energy. The activation energy is the energy that is going from energy of reactant to the maximum value that you have at this specific point. So all this here, which is very big compared to the exothermic reaction, this one here is what we call activation energy for the endothermic reaction. Of course, you need to give much more energy to the endothermic reaction to begin. So that is the activation energy. I hope this is quite clear. Now, there is two more things that we have to speak about here. There is a point which is just a point here, which is the maximum energy possible. That point is called activated complex. Activated complex for both reactions. Activated complex, and that is that point. Now, what is happening at that specific point, guys? This is the point where the reaction actually begins. So you have some energy for the reactant, stable, is constant, as you can see. You give some extra energy, which call activation energy. The energy of the reactant increases up until this specific point. At that point, which is called the activated complex, at that point is when the bonding between the reactants start to break to form new bonds for the product at that specific point. The same happens with endothermic reaction. At that specific point, which is called activated complex, is when the bonding from the reactant start to break and the new bonds start to form. And it's a very small time interval, as you can see in here. It's just a point. It's not a place, is nothing to speak about. That is the maximum energy possible. Guys, this is almost done. There is another important concept which we have to mention, and is a catalyst. You will learn about catalyst much more in grade 12, but I think we can just mention it at the moment. It's not a big problem here. So a catalyst is a substance that speeds up the reaction. There will be much more about catalysts later on in grade 12, but for now you need to know that the catalyst, what it does is to lower the activation energy. So if you add a catalyst, this activation energy won't be that high there, it will stop somewhere here. So the activated complex will be reached faster. The same with the endothermic reaction. If you add a catalyst, then the activation energy decreases and then the reaction reaches that activated complex much faster, and therefore it does, or need less energy, it does happen faster. Guys, I hope this helped. Next time we're going to solve a question related to this topic. If there is something that is not clear, be my guest. You can write questions. You can send me a message. I will answer as soon as I can. Thank you for watching. I hope it helps. Subscribe for the channel. Thumb up. Mr. G Physics here.